So this is looking at a polar defined graph, and we're trying to find, the first question says find the area underneath the x-axis. So we're trying to find this area here. And before we get into this problem, whenever you're doing polar graphs, I think it's helpful for me at least to just kind of quickly think about what the graph's going to look like. So if we generate some, our theta and r values. So when theta equals 0, r equals 1. When theta equals pi over 4, r is going to be 2 root 2 over 2, pi over 2, r equals 1. When theta equals negative, or sorry, 3 pi over 4, r is 0. And when theta equals pi, r is negative 1. Well, what's key here is we have just finished a cycle. So when theta equals 0, so that's this radial line, r is 1 right there. And when theta equals pi, r equals negative 1. Well, the negative bounces back, in the opposite direction, back to here. And looking at these points, what we see is that, from 0 to pi, we do a full revolution. Okay, that's helpful for us. It's actually very helpful for us because that gives us our limits of integration. So let me just I'm gonna erase that. So I think what's important is just to really get a sense of what the area curve is, or the area formula does. So, the idea of the area formula is that, there's some r theta point, and if theta increases, now we have theta like that. So imagine that this is just that change in theta was d theta, and this little area that we sweep out is 1/2 f of theta squared times pi. Sorry, that pi shouldn't be there. I said it, and then I was like, no, that's not right. Because remember, the idea of this area equation is that we're setting up a ratio between the total area in a circle and the area of our little sector, and that ratio should equal the total number of radians in one circle divided by our little d theta. And when we solve that and we should call this area dA, small little area. So dA equals 1/2 r squared d theta, and where r is f of theta. So that's the idea of that little area of a sector. And then the kind of integration part. Well, we're going to integrate this from this point here, which is 3 pi over 4, all the way to this point here, which is pi, 1/2 times cos theta plus sine theta squared d theta. So that's the setup of this problem. Well, okay, the rest is really just, I mean, to say it's really algebra, I mean, it's just really simple calculus. But I'm going to do that on another page. So if I have the integral from 3 pi over 4 to pi of and 1/2 cos theta plus sine theta squared d theta equals, well, let's square everything. So we get cos squared theta plus sine squared theta plus 2 sine theta cos theta d theta. And we know that cos squared plus sine squared equals 1. So we get 1/2 times 1 plus 2 sine theta cos theta. Okay, and the last thing here is just to do the integration and evaluate the limit. So 1/2 theta plus, well, this integrates, you could integrate it a couple different ways, but um, sine squared theta, and you could undo sine squared theta to see that it's actually exactly that, from 3 pi over 4 to pi. And when we evaluate our function, we get 1/2. When I put pi in, a sine of pi is 0, so 1/2 pi minus 3 pi over 4 plus root 2 over 2 squared. So um, we end up with this. That is the area underneath our graph. So we did the first part. Then it says find dx d theta and dy d theta. Well, we know that x equals r cos theta, y equals r sine theta. So if we put in what our r value is, so x equals cos theta plus sine theta times cos theta, which is cos squared theta plus cos theta sine theta. That's x. So if I differentiate it with respect to theta, dx d theta, so this is looking at how x changes as theta changes, will be 2 or negative 2 cos theta sine theta minus sine squared theta plus cosine squared theta. And this piece here, that's the derivative of cos theta sine theta, making sure that we employ the product rule. Okay. So now let's take the derivative of our y. Let's first simplify it. So y equals cos theta sine theta plus sine squared. So dy d theta equals negative sine squared theta plus cos squared theta plus 2 sine theta cos theta. So now we've found x d theta and dy d theta. The next question says find a line tangent to the curve at theta equals pi over 4. Well, let's find, we know that dy dx equals dy d theta over dx d theta. So kind of taking the time to write it out, but negative 2 cos theta, sorry, we're doing dy d theta. So negative sine squared theta plus cos squared theta plus 2 sine theta cos theta all over negative 2 cos theta sine theta minus sine squared theta plus cos squared theta. These are very similar, but just a little bit different. If we evaluate this, we need to find the slope. Since we're finding the tangent line at pi over 4, we need to find the slope at theta equals pi over 4. And when you put pi over 4 into this equation, you end up getting negative 1 back. So that's putting pi over 4 into this, and you get negative 1. And then we need to find y at pi over 4. Well, putting pi over 4 into this equation, ends up getting us 1. And x at pi over 4 also equals 1. So I don't want to spend the time doing that, but I'm just putting pi over 4 into x and into y. And when you do that, you get 1 back. So our tangent line then, our tangent line is going to be y equals our slope, negative 1, times x minus 1 plus 1. And just to generalize it, this was y equals dy dx at pi over 4, x minus x at pi over 4, plus y at pi over 4. Okay, and so that's part of that question. So we've done A, B, and C. The last thing, D, find the arc length from 0 to 2 pi. So we know that when we're dealing in polar, that arc length L and from 0 to 2 pi equals the square root of f prime of theta squared plus f of theta squared d theta. That's always the case. And just to kind of, in case you're wondering or thinking, when I wrote this problem, it's not the greatest problem because I probably should just go to from 0 to pi. This arc length is going to go from, that's pi, that's 0 to pi. And then that's 0 to 2 pi. So this actually, from 0 to 2 pi is 2 revolutions. So it's going to find twice the perimeter of this, but that's okay. So let's do this work now. We know that f of theta is that, and f prime of theta, we're talking about r. So f prime of theta equals negative sine theta plus cos theta. So the derivative, or sorry, that is the derivative. So when we square these two, we're talking about the square root of doing the derivative squared first. When you square this, you're going to get sine squared theta plus cos squared theta minus 2 sine theta cos theta plus, when you square just the function itself, we're going to get sine squared theta plus cos squared theta plus 2 sine theta cos theta. And this is the integral from 0 to 2 pi d theta. That's what our arc length will be. Well, this looks really, really, really ugly, but it actually simplifies to something very simple. That ends up being 1. This ends up being 1. And these cancel each other out. So L equals the square root from 0 to 2 pi of root 2 d theta. Amazing that it simplifies to that. Cool. Very cool. So this equals, well, when we integrate it, we get root 2 theta going from 0 to 2 pi. So we get 2 root 2 pi as our final answer. Neat problem.